7.1 example 6, using addition method when multiplication of both equations is required. Solve the given system of equations in two variables by addition. So again, this could be called addition or elimination method. Either one is fine. But let's take a look at this one. So 2, not a multiple of 5, 3, not a multiple of 10. So we're kind of forced to do some ugly work here. Let's see. I mean, technically we could divide this one by 5. It's gonna be a little bit too much work though. What we could do is eliminate the x's, because I would rather work with 2's and 5's rather than 3's and 10's. So let's work with this. What we're gonna have to do is let's get our magic number to be 10, which is our 2 times 5. Let's multiply this equation by a positive 5. Let's multiply this equation by a negative 2. That way we have a positive 10x here, negative 10x here. So that way when we add them together, we end up with 0. All right, so let's label this one equation 1. Let's label this one equation 2. So for equation 1, we have our 2x plus 3y equals a negative 16. And we want to multiply this one by a positive 5. So that way when we add them together, the x variable turns to 0. So positive 5 times 2x plus 3y is equal to a negative 16 times 5. And we have to distribute 10x plus 15y is equal to, let's do 16 times 5. So 16 times 5 is 80. And because it was a negative 16, positive 5, this ends up being negative 80. All right, so that's step 1 with equation 1. Let's do the same thing, but this time we're going to multiply by a negative 2. Again, multiplying this by negative 2 gives us a negative 10 here. So that way when we add the negative 10 with the positive 10, it eliminates the x variable. So now equation 2. We have that 5x minus 10y is equal to 30. We're multiplying this one by a negative 2. That 5x minus 10y is equal to 30 times negative 2. And we just distribute here. That's going to give us a negative 10x. Positive 20y is equal to a negative 60. Now we have these two equations that we could add together to eliminate the variable. So let's add those two together. Starting off with the left one, 10x plus 15y equals a negative 80. And the right side, negative 10x plus 20y is equal to a negative 60. Adding those two equations together, let's see what we end up with. Positive 10, negative 10 is 0, plus 15 plus 20 is going to be 35y. And that's equal to 0, a negative 140. So we have 35y is equal to a negative 140. Divide both sides by 35. I believe that's a negative 4, but let's just use our calculator just in case. Negative 140 divided by 35. Oop, I was right. We got negative 4. So far we've found our y component of our vertex. We still have to find the x component. We could use any one of these equations. We could use this one, we could use this one, we could use this one, or even this one. I don't recommend using these just in case you did make a mistake and you didn't bring the mistake over here or anything. I always recommend using one of the original problems. We're looking for x, so I'd rather work with 2's rather than 5's. So let's use that first equation. If you want to see that it'll work either way, you yourself while doing the problems, you guys could do this one here just so you could see that it ends up being the exact same solution. 2x plus 3y is equal to a negative 16. We let y equal negative 4. That's what all of this hard work was for. 2x plus 3 times y, which is negative 4, is equal to a negative 16. 2x minus 12 is equal to a negative 16. To get x by itself, let's add 12 to both sides. We have 2x is equal to 4. Divide both sides by 2. X is equal to 2. Now, if you tried the other equation, you should have gotten 2 as well, because we are solving the system of equations. And we just showed the whole world that this is how we get this solution. So might as well show it and kind of be a little annoying about it. Highlight it, show the world that you guys did the work for it. So this is a solution to the system of equations. As always, if you have any questions, please feel free to ask. Otherwise, bye.